Good morning all. In today's class, we will discuss some more concepts on threads. That is some more concepts on multi-threading. Till now, we have discussed two important concepts. There, how do we create a thread? By extending thread class and also by implementing runnable interface. These are the only two ways to create a new thread. Okay, so how do we create a new thread in multi-threading is either using by thread class or by extending thread class or by implementing runnable interface. These two programs I explained in depth. Okay, now we will see the next concept, that is how do we set a name for the thread. Okay, and how do we set a priority to a thread. So that is nothing but setting and getting names of a thread, and another concept is setting and getting the priorities of the thread. Okay, once we create a thread, we can give the names to that thread or we can give the priorities to that thread. Okay, that is nothing but setting and getting names and setting and getting the priorities of the thread. Okay, next last class I explained two approaches to write the multi-threaded programs. No, so out of those two approaches, the best one is by implementing the runnable interface is the best one. If you take the second approach, that is okay, by implementing the runnable interface, okay, in this case we can also use extends keyword to inherit the properties of its superclass. That's why second approach is the best one. If you take the second approach, we use inheritance as well as we can implement runnable interface. Okay, so that's why second approach is the best approach. If you take the first approach, we can't extend one more class because second approach means first approach means class my thread extends thread. Already our class is extending thread class. That's why you can't extend one more class. So we are missing the concept of inheritance. That's why out of these two approaches to create the thread, second approach is the better one. Next, coming to the thread class constructors. So here this is constructors, not construction. So here coming to the thread class constructors. Here try to understand one point, that is here we have two types of classes in Java. There are predefined classes and user defined classes. Okay, so whenever you create an object, whether it is for predefined class or user defined class, constructors are must. Already explained. Whenever we execute, okay, the object creation statement, compulsory one constructor must be executed, whether it is default constructor or user defined constructor. That's why when you create an object for either predefined class or user defined class, compulsory one constructor of that class will be executed. Now here one you may get one doubt. So how do we create objects for predefined classes? So already we know how do we create objects for user defined classes. You know, user defined classes are student, employee, like that, no, and box. So how do we create an object for student class? And student is a user defined class. You know how do we create? Student S1 is equal to new student. So after student we have parenthesis. So here we can take no arg constructor or parameterized constructor. We have written so many programs on no arg constructor and parameterized constructor. Okay, so whenever you create an object like student S1 is equal to new student of, you can send the parameter, you can take the arguments, okay, to invoke the parameterized constructor. Or if you won't take any arguments, then only empty parenthesis indicates that it is invoking the no arg constructor. That's why while creating the objects for your user defined classes, okay, we are taking our own constructors. But in case of predefined classes, whenever you create an object for predefined class, you cannot take the constructors as you like. So, okay, so you should take the constructors which are defined by the some people only. So they have defined the thread class. No, thread is a predefined class. Okay, so while defining the thread class, they have given the constructors of that class. So these are the constructors of the thread class. So if you see this part, this is no arg constructor, and this is constructor with one parameter. This is also constructor with one parameter, but here it is taking the parameter data type is runnable. Here it is taking the parameter data type is string. That's why try to understand all these are after new. Okay, all these are called thread class constructors. So for predefined classes, you can't write the constructors as you like. Compulsory, you should go to the API and open the thread class and check what are the constructors which are available for thread class. So this concept is not only for thread class. If you want to create any object, or if you want to create an object for any predefined class, okay, first you need to know the constructors of that class. These are also predefined constructors. Okay, so to create an object for predefined class, we should use the predefined constructors only. You cannot use your own constructors. This is one more important point regarding predefined classes. Okay, user defined classes means we are writing our own constructors. But for predefined classes, you cannot write your own constructors. So while defining that predefined class, some people they have given the predefined constructors also. So while if you want to create any object for predefined class like thread, you should use the predefined constructors only. So that is one more difference between predefined classes and user defined classes with respect to objects creation. So when you want to create an object, whether it is for user defined class or predefined class, compulsory we must use constructors. See, all these 8 are for thread class object creation statements. This is thread class object. This is also thread class object. This is also thread class object. But what is the difference between these 8 objects is here, okay, with respect to the constructor change. These are the changes. Here I am using, okay, thread class parameterized constructor. Here also parameterized, here also parameterized, but this constructor is taking 2 parameters. Like that, all these are thread class predefined constructors. So if you want to create thread object for thread class, which is a predefined class, we must use any one of these 8 constructors. So how do we know the constructors of the predefined classes is, you must go to the API, Java API. In that all the predefined classes are there. So go, if you want to know the thread class constructors, go to the API and check for thread class. So inside that the thread class, you can find out the constructors or predefined constructors of that thread class. Like that, you can go to API and you can check any predefined class and open that class. In that, you can see the predefined constructors of that predefined class. So using these constructors only, we can create thread class objects. Okay, you can't take your own constructors. So here you can't remember all these constructors, no. You can't by heart also, because here in thread class 8 constructors I have written here. Like that, we don't know any then the total number of constructors which are there in the thread class. Like that, that's why no need to by heart the predefined constructors for predefined classes. Directly, whenever you want to write a program, if you want to create an object for predefined class, okay, so go to API and find out that predefined class and find out the constructor and see the purpose of each and every constructor. So here we have 8 constructors are there now for thread class. So the purpose of each and every constructor is different. Okay, based on your requirement, you have to select which constructor is suitable for your program or for your requirement. So we have to take that constructor only. You can't take, suppose if your requirement is this one. Last class I explained one program, that is second approach. That is by implementing runnable interface. There I have used this constructor because I have created a thread by extending runnable interface. After that I have created an object for my runnable class. After that I have used this syntax for creation of thread class object, and with this I have invoked the start method of the thread class using t dots dot. So last class in the second approach I have used this object creation. Okay, and using this object creation I am accessing the start method of the thread class. Okay, see, this is the constructor which I have taken to write the program using the second approach. Like that, based on your requirement, you have to select which constructor is suitable for your requirement. So in the last class, for the second approach, I have selected this constructor. Using this constructor, I have created an object for the thread class, and with this thread class reference variable, I have invoked the start method of the thread class. Like that, based on your requirement, you have to select the suitable constructor. So this is very, very important. So what is the difference between predefined classes and user-defined classes is, for user-defined classes, we can create our own constructors. But for predefined classes, you can't create your own constructor. So here we must take the 3 predefined constructors of that predefined class to create the objects for that predefined class. This is very, very important, try to understand. Okay, but you need not by heart all these. It is very difficult to by heart now for all the constructors for all the predefined classes. Based on your requirement, if you want the thread class constructor, go to API and open thread class and find out the suitable constructor. Okay, like that, by taking the suitable constructor, I can create the object for that thread class. So in the last class, so for the second approach, I have used this constructor. Okay, that is thread of runnable, or I have used this constructor to create the thread class object. Okay, so already I have used this one. See the last class program, that is how do we create a thread by implementing runnable interface. Okay, now see the second program and try to understand the object creation for thread class with this syntax. I have used this one. Like that, how many constructors are there? 8, no? So here first one is, this is no argument constructor. This is thread with one parameter, that is the reference variable of runnable interface. Next is string name. Next runnable or comma string name. Next thread group G string name. Thread group G runnable or, like that. These are the constructors. Next we will use this constructor also while setting and getting the names of a thread. Okay, next I will explain this constructor, that is thread of string name. Okay, we can set the name of the string using this constructor. That's why each constructor has its own purpose. So that's why based on your requirement, you select the suitable constructor. So these are the thread class constructors. Okay, next concept is, we will see this one, getting and setting name of a thread. Okay, so each and every thread has unique name. Here we are writing the programs on multi-threading, means in each and every program we have more than 2 threads. Last class I explained one program that is using 6 threads. What are the 6 threads? Main is always one thread, that is main thread. The child threads are 5. Okay, each child thread is for performing one arithmetic operation. Okay, I have taken 5 threads for performing addition, multiplication, division, modulus and subtraction. Like that, I have explained one program that is with 6 threads. So now here you may get one doubt. Okay, we have written one program or one multi-threaded program with 6 threads. So what are the names of the threads? what are the names of those 6 threads. Okay, now the concept is that one, getting and setting name of a thread. Now here see this one. Every thread in Java has a name. So we can get and set name of the thread by using the following methods of the thread class. Till now I have explained only 2 methods in the thread class. They are start method and run method. So in addition to the start method and run method, we have so many methods in thread class. We will see one by one. Based on the concept, we have to select that particular method. Here our concept is getting and setting name of a thread. No? Yeah, that's why in addition to the start method and run method, inside the thread class, we have 2 more methods. They are set name and get name. So this is the predefined class. So class thread, last class I explained, implements runnable. So always thread class implements runnable interface. So the predefined class thread implements runnable. Here we can write implements runnable. So inside the thread class, we have 2 more methods. They are set name and get name, and these 2 are final methods. What is the meaning of this final method? Already you know final methods. So final methods cannot be overridden in the subclasses. So once some people have declared, okay, this set name and get name methods as final. Means last class we have written programs, that is class my thread extends thread. Thread is the superclass, my thread is the subclass. So inside the subclass, you can't override set name and get name methods. But whereas if you see run method of the thread class, so run method of the thread class is not declared with final keyword. That's why run method is not a final method. That's why we can override run method of the thread class in my thread class. That's why inside the my thread class, we have written the overriding run method, because run method of the thread class is not a final method. But whereas set name and get name methods are final methods inside thread class, that's why you can't override these methods in your class, that is in the subclass my thread. Okay, so that is final concept. Next, what is the purpose of set name and get name is? Set name is setting a name to your thread, and get name is getting the name of the thread, because each and every thread in Java has a name. Now I will explain these 2 methods with one example program, and how do we set a name for a thread, and how do we get the name of the thread after setting the name. And now try to understand this program. So class test public static void main system.out.println thread.current thread dot get name. See, thread dot current thread means what is the current thread now? Main is the thread now. So thread dot current thread is nothing but main. Main is our thread here. Okay. So dot get name. So here we are asking with this syntax, what is the name of the main thread? See, remember, name of the main thread is main only. This is the default name for main thread, which is main. Okay. Next, I have created one thread. Already before this class test, we should write one thread. That is, last class I explained, no, class my thread extends thread. In that, write the overriding run method to write the functionality of that thread. So first to create one thread. Okay. After that, write this one. So already I created one thread before this class test in the same program. After that, I am creating the object for that my thread, that is my thread t is equal to new my thread. After that, what I am doing is system.out.println t.getName. So I am getting the name of this child thread. Previously, I know the name of the main thread using the getName method. GetName method will return the name of the method. That's why the return type of getName method is string. Using getName method, we are getting the name of the thread. That's why the return type of getName method is string. So here, using this getName method, I am getting the name of the main thread, that is main. Next, using here t.getName, I am getting the name of the child thread. So what is the output here is thread 0. So why it is thread 0? So remember, So by default, okay, each and every thread has default name. So the default name for main thread is main only. In the same way, the default name for the child threads are thread 0, that is the first thread default name. Next thread 1, second thread default name. Thread 2, like that. The child threads names are given in the order. First thread 0, thread 1, thread 2, thread 3, like that. But in this program, I have created only one thread. That's why when you want to get the name of that thread, it will give you the default name as thread 0. Because I have set the name for this thread. Unless you set the name for the thread, the default names are, the default names for the child threads are, okay, starting with thread 0, thread 1, thread 2, thread 3, like that. Last class I explained a program with 6 threads, no? That is, main thread is there. In addition to the main thread, I have taken my thread 1, my thread 2, my thread 3, my thread 4, and my thread 5 for performing arithmetic operations, no? So if you write that program, and if you create an object for each and every thread, after creating an object for each and every thread, if you write t1 dot get name, so for the first thread it will give you thread 0. Next t2 dot get name, okay, it will give you thread 1. t3 dot get name, it will give you thread 3. 0, 1, 2, no, thread 2. Next t4 dot get name means thread 3. Like that, it will give you the default names which starts with thread 0. Unless you set the names for the threads, the default names for the child threads are thread 0, thread 1, thread 2, thread 3, like that in multi-threaded programs. Always the default name for main thread is main. Next, after that, this is the default name. No? Next, what I am doing is, after that, I am setting the name for my child thread. So you can set your names for threads. If you don't like default names for the child threads, you can set your own name. Like that, for main thread also, you can set your own name, not only for the child threads. So we can set, okay, our own names for any thread. Means for main thread, we can set with your own name using set name method. So if I write thread dot current thread dot set name, okay, set name of, okay, I will write here Raju. Then this main thread, now the main thread name is Raju. Like that, we can set your own name for main thread also, and in the same way we can set, okay, we can set with our own names for child threads also. Next, here till now we have not set the name for our this child thread. So if you won't set, the default name for main is main, and the default name for child thread is thread 0, because here only one child thread and it starts with thread 0. Okay. Next, after that, I want to set, okay, my name for this child thread. How do I set the name for this child thread? Using set name method. So t is the reference variable. T dot set name of Vasu, because set name is taking the parameter as string type. That's why put in double quotes. So t dot set name of Vasu. So after setting the name for this thread with Vasu, if you want to see, okay, use get name. So system.out.println t dot get name. So the answer is Vasu. See, previously, unless you set the name for the child thread, it is giving thread 0. But after setting the name to your child thread, it is giving our own name, that is Vasu. Like that, we can set and get the names of the threads. Default also we know. Here you may get one doubt. Here I have used thread dot current thread. No? What is the meaning of thread dot current thread? So here it will show you current object and current executing thread, both are not same. So current object reference we can get by using this keyword. Already explained. This refers to the current class object. But currently executing thread, because we have so many threads, no? Which thread is executing currently, we don't know. Okay? Which thread is given the CPU, by the thread scheduler. That thread is called currently executing thread. No, that's why currently executing thread reference we can get by using thread.currentThread method. Okay, so this is okay. This refers to the current class object. Like that, thread.currentThread refers to the currently executing thread reference. Current object reference and currently executing thread reference using this and thread.currentThread. So this is a program on that. Now you can easily understand. Okay, see that program. What is the next concept is thread priorities. Okay, here thread priorities means previously we have written two programs now. In those two programs, the two threads, main thread and child thread, are having equal priority. That's why we can't expect the output if the threads are having equal priorities. But if you want to execute one thread first, okay, then we have to set the priority. That is nothing but the thread priorities. So every thread in Java has some priority. So the valid range of thread priorities are 1 to 10. Already explained in exception handling. Okay, so every thread in Java has some priorities. Based on the priorities of the threads only, the thread scheduler will allocate the CPU to that particular thread. In the last class, I explained two programs. There we have two threads which are in the waiting queue, and both the two threads are having equal priority, that is 5. So the default priority for each thread is 5. Unless you set the priority for any thread, okay, by default, the default priority for each and every thread is 5. That's why in the last class two programs, we have not set the priority to the threads for main thread and child thread. That's why what are the default priorities for main thread and child thread is, for both it is 5. That's why when they are in the waiting queue, both main thread and child thread, both are having the equal priorities 5. When both the threads are having the equal priority means, okay, then we don't know which thread is given the CPU first by the thread scheduler. Because both the threads are having equal priorities, that is the default priority is 5. So both the threads are having the priority 5 in the previous two programs. That's why if you see the output for the previous two programs, that is by extending thread class and by implementing runnable interface, you can't expect the output. The last class already explained. So the only we can write the possible outputs. You can't write the exact output when all the threads are having equal priority. That is the concept of thread priority. Suppose if you want to execute one thread first, then you can set the priority. You can set the highest priority to that particular thread. So while allocating the CPU for any thread, okay, the thread scheduler will check the priorities first. So if priority is given for a thread by the programmer, okay, then the thread scheduler will consider the priorities, and based on the priorities only, the thread scheduler will allocate the CPU. Means the thread which is having the highest priority is given the CPU by the thread scheduler. That's why if you want to execute any thread first, means if you are giving any priority for any thread, so set the priority as the highest priority for that thread. In that case, the thread scheduler will consider the highest priority thread first, and it will allocate the CPU for the highest priority thread. So like that, thread priorities are also very, very important. Okay, now we will see here again. Inside the class thread, till now we have seen 4 methods of the thread class. Okay, so what are the 4 methods of the thread class till now? We have seen start method, run method, and set name and get name methods. So like that, inside the thread class, we have these two. What are these? Constants are also there. So inside any predefined class or user defined class, we can write constants as well as variables. So here inside thread class, we have constants. These are the three constants. So constants means how do we identify? We have to take all uppercase letters for constants. Okay, so here how many constants are there inside the thread class? Three constants. That is norm priority, min priority and max priority. So min priority is 1 and norm priority means 5 and max priority is 10. You know the priorities are in between 1 and 10. That's why here min priority 1, norm priority 5, max priority 10. So the default priority is norm priority, which is 5. Unless you give the priority to any thread, the default priority of that thread is 5 using this norm priority. And all these constants are declared with static keyword. That's why outside the class, static constants of this class can be accessed with class name dot that constant name. That's why thread dot norm priority, because these are declared with static keyword. Okay, remember these three are the constants: norm priority, min priority, max priority. There is no such concept like low priority, high priority. Only these are the three constants, predefined constants, which are static constants, which are declared in the thread class. Okay. Next. Okay, in addition to those three constants, we have two methods also. That is set priority, like set name, set priority, and get priority, like get name. See, set priority method is a final method. Means you can't override set priority method in your class. Means in class my thread you can't override because it is declared with final. These two methods are also declared with final, like set name and get name methods. Okay, but here set name method is taking string as parameter now to set the name of a thread. But here set priority is a method which is taking integer parameter, because the allowed values for the priorities is in between 1 to 10. So here you can give in between 1 to 10. If you give -1 or if you give 20 like that, you will get already explained illegal argument exception. So here the parameter for the set priority method is an integer, and the allowed values for this integer is in between 1 and 10. If you give more than 10 or less than 1, then you will get illegal argument exception. Means that is not legal. Legal values for integer, this int parameter is 1 to 10. Okay. Now here both set priority method and get priority method. See, get priority method is returning the priority of that thread, because each and every thread has priority, no? So here remember two concepts in multi-threading. Each and every thread has unique name. Like that, each and every thread has priority. Unless you set the priorities for the threads, the default priority is 5. That is norm priority. If you want to set the priority, you can set the priority for any thread, or you can set the priority for all the threads, including main thread also. So these two are also very, very important methods, and the thread priorities concept also very, very important. So in the thread priorities, you can see the concepts. Three constants are there: norm priority, min priority, and max priority. And two methods are there. They are set priority and get priority. Now try to write a program using these two methods. Okay. Now here thread scheduler use these priorities while allocating the CPU. The thread which is having the highest priority will get chance first for execution. If two threads having the same priority, okay, then we can't expect exactly which thread will get chance first for execution. So it depends on the thread scheduler. Okay, whose behavior is JVM vendor dependent. Okay, when two or more threads are having the same priority, then nobody knows which thread is given CPU by the thread scheduler. It depends on this one, whose behavior is vendor dependent. And one more concept is, if the thread is having highest priority among all the threads. If one thread is having highest priority among all the threads, definitely that thread is given CPU first by the thread scheduler. That is the concept of thread priorities. Okay, so thread class defines the following two methods to get and set the priority of a thread. So get priority, set priority, it is taking integer argument and range is 1 to 10. Suppose if you give a value which is outside the range 1 to 10, then you will get illegal argument exception. Already we have written a program in exception handling for this illegal argument exception. Same I have taken there 20. Okay. Now we will write a program using this get priority and set priority methods, and these are final methods, means they cannot be overridden in the subclasses. Next, the default priority of any thread is 5. Like that, the default any thread is 5. I explained now why the default priority of any thread is 5. The reason is there. I will explain. So the default priority of any thread is 5. Means unless you set the priority for any thread, the default priority of any thread is 5. Why it is 5? I will explain with this. Okay. The default priority of main thread is 5. First, understand like this. But for all the remaining threads, okay, they will be inheriting from the parent thread. That is, whatever parent thread has, the same priority will be inherited to the child threads. So here in all the multi-threading programs, okay, main is the main thread and the remaining all are the child threads. I have explained one program with 6 threads now. In that main thread and 5 threads are there for 5 arithmetic operators. So in those 6 threads, main is called main thread and the remaining all 5 are called child threads. There is only one main thread, that is called main. So here it is saying the default priority of main thread is 5. And the remaining threads priorities, they are inheriting or they will be taking the priority of its parent thread. So here parent thread is called main thread and the remaining all threads are child threads now. Okay. So here what is this concept? The default priority of main thread is 5. Default priority of main thread is 5. So when the default priority of the parent thread, that is main thread, is 5, then remaining all child threads are inheriting the priority from its parent thread, that is main thread. So when main is having the priority 5, then the remaining the child threads, they are also having the priority 5. Why? Because all the child threads are inheriting the priorities from its parent thread. Here only one parent thread, that is main thread. Okay. So main thread is having 5 means priority. The default priority for the main thread is 5 means for all the child threads also the priority is 5 only, because all the child threads are inheriting the priority from its parent thread, that is main thread. That's why in the previous 2 programs, the priorities of those 2 threads, we have written 2 programs no? In those 2 programs, we have only 2 threads. They are main thread and child thread. Here I am saying the default priority of the main thread is 5. Then what is the priority of what is the default priority of the child thread? It is also 5 based on this rule. All the child threads are inheriting the priorities from its parent thread. So if you see the previous 2 programs, so there is only one main thread, that is main, and we have created only one child thread, that is my thread. Okay. So in that case, the priority of the main thread is 5. So the priority of the child thread, that is my thread, also 5. So when these 2 threads are having the equal priority 5, what will happen? We don't know the exact output. Means which thread is given the CPU first by the thread scheduler, nobody knows. That's why we can't expect the exact output when the threads are having the equal priorities. If you see the priorities of the threads in the previous 2 programs, for both the threads it is 5 only. Why? Because the default priority for main thread is 5 and it is inherited to its child threads. That's why the child thread priority is also 5. So when both the threads are having the same priority, which is 5, then we can't expect the exact output. That's why we can write only possible outputs. Okay. That is the concept of this. After that, we will write one program using set priority and get priority methods of thread class. Okay. Now class my thread extends thread. So we have to create a thread like this first. So without creating a thread like this, you can't use the methods set name, get name, like set priority and get priority. At least minimum 2 threads must be required. One is child thread, this is child thread, and this is main thread. With respect to these 2 threads, I can explain the concepts of set name, set priority and get priority. That's why at least minimum 1 thread create. Otherwise, you can't explain multi-threaded programs. You can create any number of child threads, but at least 1 child thread is must. Okay, like that's why to explain the concepts in each and every program, I have taken only 1 child thread. Otherwise, the program will be very lengthy. No, you can't understand. So first understand the concepts. Once you understand the concept with 1 child thread, like this 1 child thread, you can write any number of child threads. No, already I have created 5 child threads for arithmetic operators. My thread 1, my thread 2, my thread 3, my thread 4, my thread 5. Like that, once you understand all the concepts with 1 child thread in addition to the main thread, you can understand, okay, multi-threaded programs with any number of child threads. Okay, always main is called main thread. Now I will explain this program. So class my thread extends thread means this is 1 child thread. Okay. Next class test, this is the main thread. Inside the main method, what I am writing, system.out.println thread dot current thread dot thread get priority. Now here I am, okay, I am trying to know the what is the priority of this main thread. So how do we know the priority of the main thread is using thread dot current thread. So how do I write system.out.println thread dot current thread dot get priority. Now we have not set the priority for the main thread till now. Unless you set the priority for the main thread, what is the default priority of main thread? Is 5. That's why if you use the get priority method on this main thread using thread dot current thread dot get priority, it is giving 5. Next, thread dot current thread dot set priority. Okay, thread dot current thread means till now I have not created an object for the child thread. No, means of this is also for main thread only. So thread dot current thread dot set priority of 10 means previously the default priority of the main thread was 5. Now I want to set the priority for the main thread as 10 using set priority method, because the allowed values are 1 to 10 only. That's why I have taken 10. So when you set the priority for the main thread with 10, okay, if here we are setting thread dot current thread dot set priority of 10 means, okay, this the priority 10 will be set to the main thread. After that, if you write thread dot current thread dot get priority, okay, it will give you the output as 10. Now, previously, before setting the priority to the main thread, what is the default priority? 5. So after the setting the priority to the main thread with the set priority method, okay, after that, if you want to know the get priority of the main, okay, after that, if you want to know the priority of the main thread, you can see using thread dot current thread dot get priority. So here you will get the output as 10. Like that, we can set and get the priorities of any thread. So these two are for main thread. So after that, try to write it like this. Otherwise, if you set the priority, you don't know whether that priority is set to this main thread or not. That's why if you want to know whether that priority is set to the main thread or not, immediately you write the statement thread dot current thread dot get priority, no arguments. So it will give you the output as 10. Okay. So up to this is for main thread. Next, after that, I am creating the object for child thread. This is my child thread. No. So my thread t is equal to new my thread. So after that, if you want to know system.out.println t dot get priority. So what is the output? What is the output? Is it 5 or 10? It is 10 only. Why? Because see here, for initially the main thread priority is 5, default priority. After that I have set the priority for the main thread as 10. Now here 10. The main thread priority is 10. Means it is inherited to its child thread, no? This 10 is inherited to its child thread. That's why if you see the priority for this child thread using T dot get priority, we can see. That's why it is 10 only. It is not 5. Why? Because initially the main thread priority is 5 only. But after that I have set the priority for the main thread with 10. Means now latest value for the main thread is 10 now. Now 10 is inherited. The priority of the main thread, that is parent thread, which is 10, is inherited to all its child threads. That's why if you want to know the child thread priority, after setting the priority for the main thread, you can see the output is 5. 10, not 5. 10, because that this is the latest priority of the main thread. That's why here this latest priority is inherited to its child thread. That's why it is giving 10 only. Suppose if you won't write this statement, means if you won't set the priority to the main thread, then what will be the answer for this is 5 only. If you won't set the priority for the thread, main thread, the default priority is 5. No? In that case, that 5 is inherited to its child thread. So if you put comments for this statement, put comments for this statement, in that case the answer will be here it is 5 only. If you set the priority, means the latest priority of the main thread is inherited to all its child threads. That's why it is 10. So if you use set priority of 10, then it is 10. If you comment this statement, it will be 5 only. Next here you may get one doubt. So here it is inherited from its parent thread, no? That is the main thread, no? This 10 is 10. Here we are getting the value 10 because it is the priority of its parent thread, that is main thread. But here you may get one doubt. Can we set the priority to each and every child thread? Yes. If you want to set priority for each and every thread or child thread, you can set. How do we set the priority for each and every child thread is here I will explain. This is the child class object, no? That's why here what I will write is this one. What is this one? T, no, name of this one. T dot set priority of 7. So I can write, see, remember this, see, carefully, listen carefully. How do I set the priority for the child thread? That is T dot set priority of 7 I will write. Means in this case, the priority for this child thread is set as 7. After that, if you write the statement, that is system dot out dot println T dot get priority, then you will get 7 only. In that case, you won't get 10. So where we should write set priority? If you don't want to take this child thread doesn't want to take the priority of its parent thread. In that case, this child thread can set its own priority. Okay. So in that case, where do we write that set priority for this child thread is in between these two statements, right? In between these two. That is, tell me, T dot set priority of 7. Then after that, this statement is there. And then in this case, this here the output will be 7. And suppose here, if you want to execute the child thread first, then only if you want to execute the main thread, then in that case, you change the priorities like this. So the thread dot current thread dot set priority, take it as 6. Okay, you set the main priority thread as 6, and here when you write the statement T dot set priority of 9 you write. Means in this case T dot set priority of 9 if you write, in this case child thread is having priority 9 and main thread is having priority 6. So in this case these two threads are in the waiting queue or in the ready queue. So when these two threads are there in the waiting queue with the priorities, That is the priority of the main thread as 6 and the priority of the child thread as 9. Then the thread scheduler comes into the waiting queue and it has to allocate the CPU, okay, for only one thread. So which thread is allocated the CPU by the thread scheduler is child thread only. Why? Because child thread priority I have set as 9 and main thread priority I have set as 6. That's why the child thread is given the CPU by the thread scheduler first. So after once the child thread got the CPU, then after completion of this child thread functionality only, then the thread scheduler will allocate the CPU for the main thread. So that is the advantage of this setting the priorities to the threads. So here child thread is having the priority 9, no? Means when the thread scheduler allocates the CPU to the child thread with the priority 9, then what will happen is, so after completion of the functionality of the child thread, okay, only the thread scheduler will allocate the CPU for the main thread. First, in this case, the child thread completes its execution. Completes means if you write for loop 10 times in the child thread, that for loop is repeated 10 times, you will get the entire output for the child thread followed by the main thread output. Because here it is child thread is having the priority 9, main thread is having the priority 6. That's why after completion of this child thread functionality only, the thread scheduler will allocate the CPU for the main thread. So that is the advantage of thread priorities. Okay. Next you can see this program also. So class my thread extends thread means this is one thread. Already explained in depth about how do we define or create a thread. Next after that, this is child thread. Next after that, take one main thread. Next after that, what I am writing? So T dot. So this is main thread. Next I am creating an object for child thread. After that I am writing T dot set priority of 10. Next T dot start. Start means our thread is registered with the thread scheduler with the start method of the thread class. This is the functionality of the main method. So don't put comments. Okay, remove these comments and try to understand this program and tell me the output. What is the output? Now I will explain. Here what is the main thread priority? 5 only, no? Next here what is the child thread priority? 10, no? So the default priority for main thread is 5. Here it is not inherited to its child thread. Why? Because the child thread has set its own priority with 10. That's why the main thread priority is 5, child thread priority is 10. So which thread is given the CPU by the thread scheduler? A thread which is having the highest priority, no, the answer. So here the child thread is having the highest priority over the main thread. That's why first child thread will complete its execution. So if you see the output for this one, first child thread completes its execution because it is having the highest priority over main thread. That's why if you see the output for this program, then you will get the child thread 10 times. Means this for loop is executed 10 times and it completes its execution. After completion of child thread execution only, the main thread will complete its execution. This is the main thread functionality. So if you remove this these comments and then if you see the output, then what will happen? The output is child thread 10 times and main thread 10 times, because here child thread is having the highest priority and it completes its execution. After that only main thread will start its execution and it completes. So if you see the output for this program, child thread 10 times followed by main thread 10 times. Next here one more point. Suppose if I put comments in the previous concept, I have removed the comments, no? Now if I put the comments for this statement, what will be your answer? Then what will happen? Already explained, no? The default priority for main thread is 5. So the default priority of main thread is inherited to its child thread. Okay, that's why there is no statement here. Putting comments means the child thread is not setting its own priority. Then the default priority of main thread is inherited to the child thread. That's why here in this case, main thread is having the default priority 5 and child thread is also having the priority 5. Okay, putting comments this statement. So the child thread is also having the priority 5. So here main thread and child thread both are having the equal priority, which is 5. Now when these two threads are waiting in the waiting queue with same equal priority 5, 5, then we don't know which thread is given the CPU by the thread scheduler. That's why here in this case we can't expect the exact output. Like that, here we can say only possible outputs. But if you remove these comments and if you use this statement, the output must be first child thread 10 times followed by main thread 10 times. Or you can suppose if you want to execute your main thread completely first, then in that case how do we write it? So write the same program in different ways and try to understand the concept. So if I want to set the priority, that is the highest priority to main thread, then what I will write is here, this one, thread dot current thread dot set priority of, I will write here 10. Okay. After that, here t dot set priority, I will write here 6. Suppose if you set the priority for the main thread as 10, it is inherited to the child thread, no? That's why both 10, 10, well, same thing happens. That's why when you set the thread priority for the main thread as 10, next again set the priority to the child thread also, which is 7. So here it is having 10, it is having 7. So in that case, if you see the output, okay, the output is first main thread completes its execution. That's why main thread 10 times followed by child thread 10 times. So these are the different ways to set the priorities to the main thread and child threads. If you understand the concept, you can write the programs on your own. Okay, so here these are the points. If we are commenting line 1, then both child thread and main threads are having the same priority, which is 5. Hence, we can't expect the exact output. Next, if we are not commenting line 1, then child thread has a priority 10 and main thread has a priority 5. Hence, the child thread will get chance first, followed by the main thread. In this case, the output is this one. If you want to execute main thread first, followed by child thread, then set the priority for the main thread as 10 and set the priority for the child thread as 7, like that. Then in that case, your output will be first main thread 10 times followed by child thread 10 times. So understand the concept of thread priorities and write the programs differently. Next class, I will explain the methods to prevent a thread from execution. These methods are very, very important. Yield, join, sleep. So we can prevent a thread execution by using the following methods. These 3 methods are also very, very important. In addition to these 3 methods, we have one more method, that is interrupt method. So what are these 3 methods? Yield, join, sleep. Next method is interrupt. These 4 methods are very, very important. Okay. So here, what is the purpose of these methods is we can prevent a thread from execution by using the following methods. So these are the methods to prevent a thread from execution. So today I will explain these 3 methods.